Look up on the next clear winter night, find the constellation Orion, and trace his shoulder to a single point of light burning a deep, smoldering orange. That star is Betelgeuse. Betelgeuse is a red supergiant of staggering proportions. If it replaced our Sun today, its surface would swallow Mercury, Venus, Earth, and Mars, stretching all the way to the orbit of the asteroid belt. That massive boundary sits roughly 550 light-years away. The light reaching your eyes tonight left the star around the time the printing press was beginning to change Europe, arriving as a message in a bottle 5 centuries late. When its core finally runs out of fuel, Betelgeuse will collapse and rebound in a supernova, bright enough to cast shadows at night. In late 2019, the star dropped to 40% of its usual brightness. Astronomers watched closely to see if the final collapse had begun. While the world watched for an explosion, the universe used this chaos to obscure a different, quieter tragedy occurring in the giant's shadow. To see through the dimming, a team used the European Southern Observatory's Very Large Telescope in Chile to resolve the actual surface of the star. They found that Betelgeuse's massive convection cells had belched out a planet-sized bubble of gas. As that gas drifted outward and cooled, it condensed into solid grains, creating a dark veil of stardust that shaded the star from our perspective. This chart tracks the star's brightness over time, showing a secondary rhythm hidden beneath the short-term fluctuations. For decades, astronomers have measured a steady 6-year beat that didn't fit the models of how a single star should behave. A long-standing hypothesis suggested this pulse was driven by a hidden companion star, circling the supergiant and nudging its rhythm from within the glare. Finding that companion was historically considered impossible. Any secondary star would be so close to the lighthouse glare of the supergiant that it would remain effectively invisible to conventional telescopes. Decoding that 100-year-old rhythm would require a methodology designed to see past the limits of atmospheric distortion. The solution came from NASA scientist Steve Howell, who pivoted away from building larger telescopes to focus instead on defeating the Earth's atmosphere. Howell used a technique called speckle-imaging, taking thousands of millisecond-long snapshots to freeze the air's turbulence in each frame. By combining those thousands of sharp moments, he mathematically removed the blur. Pointing this camera at Betelgeuse, he found a faint point of light hiding in the glare. This is the definitive sighting of the companion star, a blue-white sun roughly 1.6 times the mass of our own. The companion follows a tight path that takes exactly 6 years to complete. As it plows through the thin outer layers of the giant's gas, it creates a rhythmic disturbance, the physical wake that explains the century-old mystery of the star's pulse. This 6-year rhythm is the physical footprint of a sibling star, hiding in plain sight for a generation of astronomers. Astronomers named the companion Siwarha, an Arabic word meaning her bracelet, a delicate object circling the giant's wrist. The bracelet is locked in a decaying orbit. Every passage through Betelgeuse's outer atmosphere creates friction, bleeding energy away from the smaller star and pulling it closer to the supergiant. This friction is slowly tightening the orbit. Within 10,000 years, Siwarha will fall into Betelgeuse and be consumed whole, ending the lives of 2 stars that were born together. Betelgeuse itself has a longer timeline. It likely has tens of thousands of years of helium burning left before it reaches its final collapse, potentially outlasting recorded human history several times over. Humanity spent the winter of 2020 fearing the death of the giant, unaware that the only star destined to vanish soon was the tiny companion orbiting quietly in its glare.